All right, guys, so in this video, we're going to be covering section 7.3, which covers triangle proportionality theorem. All right, so in this section, we have a couple things that we're going to be covering. The first thing is triangle proportionality theorem, which states that if a line is parallel to one side of a triangle and crosses the other two sides, then it divides the sides into segments of proportional parts. So for example here, if we got two different triangles here, or we really have one big triangle and then line DE and AC are parallel to each other, then that means that segment BD over DA is going to be equal to BE over EC. So if DE is parallel to AC, then that means that BD over DA is equal to BE over EC. So for example, we got this triangle right here. We know that this piece is 12, this piece is 14, this one's 15, this is X, and we know these two lines are parallel to each other because they've got those arrows on them. Then that means we can say 12 over 14 is equal to 15 over X. So there's different ways that you can set up your proportion. So for example, if you did 12 over 14, like if you swap these, you just need to make sure that you swap these as well. So you gotta match like with like whenever you're doing your proportion. So got a proportion, wanna get rid of my fractions, I'm gonna cross multiply. So I've got 12 times X gives me 12X, 15 times 14, that gives me 210. And then I'm just gonna divide by 12 on each side, get X by itself. And so I've got X equals 17.5. On question 2 here, it's the same exact thing. I know this is X, this is 18, this one's 56, and this one's 21, and these two lines are parallel to each other. So I can just say X over 18 is equal to 56 over 21. And so I'm going to cross multiply again, get rid of these fractions. 21 times X gives me 21X. 56 times 18, that equals 1008. I'm going to divide by 21 on each side. And so X is going to equal 48. All right. In this one, it's a little bit harder. They tell us the entire thing is 55. This part is 45. So in order to get this part right here, we just do the whole thing, 55 minus 45, and we're going to get 10. So now that we have that missing part, we can set it up just like we did in questions 1 and 2. So I can say X over 36 equals 10 over 45. I'm going to get rid of the fractions, cross multiply. 45 times X gives me 45X. 36 times 10 gives me 360. Divide by 45 on each side. And we get X equals 8. And again, on question 4 here, they give us a whole thing is 27. This little part is 6, so 27 minus 6 gives me 21. And then I can set it up just like the rest of them. So I'm going to have X over 7 equals 21 over 6. Cross multiply, get rid of those fractions. I'm going to have 6X equals 147. and then I divide by 6 on each side, and x equals 24.5. All right. Now, this part looks very different, but it's exactly the same kind of concept. So proportional parts and parallel lines. If we have 3 or more parallel lines intersect 2 transversals, then the parts of the transversals are proportional. So, for example, if we got 3 lines that are parallel, and then we have 2 transversals, right? So since these lines are parallel, then I can say that AC over CE is equal to BD over DF. So if AB is parallel to CD, which is parallel to EF, then that means that AC over CE is equal to BD over DF. So for example, they tell us that these 3 lines are parallel, and we know that because they have the arrows on them. Then that means that this part over this part equals this part over this part. So we can say 45 over 18 equals 52 over x. And then we just solve it just like we've been solving them. So cross multiply, 45 times x gives me 45x. 52 times 18 gives me 936. And then I can just divide by 45 on each side. And so x equals 20.8. And again, if I'm going through it kind of quick, you can always just pause and rewind, go back and forth like you need to. All right, another one just like this. We got parallel lines and then 2 transversals, so we can say that 30 over 12 is equal to x over 14. We can cross multiply to get rid of the fractions. We got 12 times x gives us 12x. 30 times 14, that gives us 420. Divide by 12 on each side. And we're going to get x equals 35. All right, these last two, a little bit more difficult because we've got binomials in them, but it's still the same concept. So we've got parallel lines all the way across. And so we can say this part over this part equals this part over this part. So I'm going to say 24 over 18 equals 3x plus 1 over 12. I'm going to cross multiply to get rid of the fractions. And when you cross multiply and you multiply a binomial, remember that you are multiplying this 18 across all parts of the binomial. So I'm going to have 18 times 3x plus 1 equals 24 times 12, which gives me 288. And from here, you can actually do 2 different ways. You can distribute this 18 onto each part of the binomial and then simplify and solve. Or what I like to do is I like to just divide by that 18 at the beginning and just get rid of it immediately. So the 18's cancel, and I'm left with 3x plus 1. 288 divided by 18, that gives you 16. And it just makes it a whole lot easier so I don't have as big of numbers. So subtract 1 on each side. That gives me 3x equals 15. Divide by 3. And so I'm going to get x equals 5. And this one, same exact concept. So there's different ways you can set up your proportions. I set mine up as 2x plus 2 over 21. So this part over this part equals x plus 3 over 12. So we got this part over this part. I'm going to cross multiply. I'm going to get 2x plus 2 times 12 on one side equals 21 times x plus 3. All right, since I have, it looks similar on both sides, I actually am going to distribute this time. Just makes it a whole lot easier so I don't have decimals. So 12 times 2x gives me 24x. 12 times 2 gives me 24. Equals 21 times x gives me 21x. 21 times 3 gives me 63. Now, what I want to do is I want to get all of my x values on one side and all of my constants on the other side. So I'm going to move this 21x to the left side. So I'm going to subtract 21x. And that gives me 24 minus 21 gives me 3x. I still have the plus 24. Equals, these cancel, and I'm left with 63 on the right side. Subtract 24. On the left side, I'm left with 3x. On the right side, I'm left with 39. And then divide by 3, get x by itself. And I've got 39 over 3, which simplifies to 13. And that's basically it. It's really the same concept for both pages. Just remember, if you have parallel lines running across like this, then their parts are going to be proportional to each other. In both, if you have triangles or if you just have parallel lines and two transversals. It's the same exact concept. All right, so that's all of the video that we have. The rest of this class period, you're just going to be working on, we got 2 pages of practice, page 13 and page 14. And then we also have the Delta Math, which remember that's going to be due on test day, which is the 24th. So make sure that you're getting that done, keeping up with it. And if you got any questions, feel free to just message me on Canvas and I can be able to help.